I'm Colin. I run the site Circuitastrophe. If you've ever been there, but it's a collection of schematics and data sheets and the best board and some of the stuff that I built is up there. And yeah, so that's me. I wanted to get like a little bit of a gauge of who you guys were, what your experience was, and what you wanted to learn and that kind of stuff. Also, if you have like a website or some way that I might have like met you on the internet, or have some association to go on the internet. If you have that, that'd be cool. So you want to start? What's that? Say like, what's your name? Do you have any like a website or anything, or if not, it's totally cool. And also like what your experience is and what you want to do. I taught a class in circuit bending at a college up near Cleveland 2 years ago. This is sort of how I classified it. When you bend something to connect 2 points, in one way or another, you're doing one of roughly 5 things. You're changing the resistance between 2 points, the capacitance, inductance, voltage, or you're doing something else that you can't describe. So we're really going to focus on the first and last, so I won't really worry about explaining what I mean by changing capacitance or inductance. It's not really what I'm worried about. But so say you have a keyboard and you connect 2 points and it glitches out. There's all kinds of weird stuff. Like, what are you actually doing? You're creating, you're having a wire path between the 2 points, so you're changing the resistance between those 2 points. You're making the resistance 0. There's no resistance. The path is perfect between these 2 points. So, like when you put in a switch, that switch either doesn't connect or it does connect. So it either has infinite resistance, it doesn't allow it to connect at all, or it has no resistance, it connects perfectly. If you guys have ever used potentiometers, or if you've ever bent with a resistor in the circuit, resistors are these little components where there's like a little can part with stripes on it and leads on either end. I have some there, but let's talk about them. And a potentiometer is a little device where there's a part you can turn on it. that, you're varying the resistance, but it's not 0 to infinity or 0 to a huge number. It's something in between. And so that's what I mean by change in resistance. Sometimes when you're bending, you're also doing a change in voltage. When you connect 2 points, you might be sending a voltage across the circuit to where it should go. But in essence, these are 2 very similar things, which is what we'll get into. So, sort of the point of my lecture is that if you have a resistive bend, if you have a switch bend, if you have a pot bend, if you have a switch bend with resistors in it, then you can essentially voltage control that. And what I mean is that you can automate that. And I'll explain what I mean by voltage control in a minute. But it's basically going to split the lecture into 2 parts, either like a digital control or analog control. Digital basically means on or off, 2 different things. Analog can be anything in between. So if you think about like a switch, it would be a digital thing. It's not digital per se, it's not like a computer, but it's either on or off. Potentiometer, it's analog. It goes from 0 to 100 and everything. So, like I said, 2 different parts of this lecture. We're going to talk about controlling analog things, controlling variable resistances, where you'll find with a lot of bends, if you connect 2 points, something will happen, but if you connect 2 points with a potentiometer, you can vary the amount that happens. And I don't know if you're familiar with that, but that's something we can do later when we're soldering. When you're controlling digital stuff, there's a lot more that you can do than just putting a switch in there. You can use like a sequencer, for example, to switch different bends sequentially. You guys may have seen this in the past, but there'll be a little device with different LEDs going on individually, and that's switching on different bends. Or I mean, it could be doing a lot of things, but one thing you can do with that is you can switch on a bend after bend after bend. You can get kind of weird, cool effects with that. So yeah. So what do I mean by control voltage? You guys are probably familiar that batteries, power supplies set up a voltage, and that powers the circuit. What's done in a lot of circuits, especially synthesizer circuits, is voltages are actually used to control things as well. So you have some sort of signal, some sort of voltage that's being sent to a circuit that controls a parameter. If you guys are familiar with the term voltage controlled oscillator, voltage controlled filter, these are circuits where a voltage is controlling a specific aspect. So for example, the frequency of an oscillator. If you ever hear like an oscillator where the frequency sweeps up and down, or it pops up and down, the frequency just kind of alternates, it's probably voltage controlled in some way. They might not really think it is, but in a way, it probably is. And most synthesizers, like analog synthesizers, use voltage control in some way. Just some typical ranges. This might not be relevant, but it's good to think about. Most analog synthesizers run on plus or minus 15 volts as their power supply. And typically in an analog synthesizer, the control voltage is either plus or minus 5 or plus or minus 10 volts. A lot of the toys we're going to be messing with, a lot of handheld devices use 9-volt batteries. Typically control voltages in there go from 0 to 5 volts. And a lot of toys also use, like, if you ever have like 4 AA batteries, it's powering with 6 volts, it probably regulates it to 5 volts. And typically in those circuits, the control voltage is also about 5 volts. And that's also 5 volts is traditionally associated with digital circuits, which we'll get to later. So I was saying a minute ago that if you hear an oscillator where the frequency is swooping up and down, it's probably voltage controlled in some way. That's because voltage, varying voltage, can be a varying resistance. So your potentiometer varies, like say you have a 1K potentiometer, 1 kilo ohm. You can vary the resistance from 0 to 1,000 ohms, or 0 to 1 kilo ohm. Well, because we're able to convert a control voltage to a resistance, we can use a varying signal to do that automatically. Well, so how do you convert voltage, a varying voltage, to a resistance?